Good afternoon, class. We want to continue with our lesson today. The last class we talked about equilibrium of forces. We are continuing with the second part of it, the subtitle. Here we want to talk about the moment of a force, couple, principle of moment, center of gravity, then the effect of center of gravity on stability of objects. So at the end of this class, you should be able to explain what moment of a force is. Then you should be able to define and explain couple. Couple is C-O-U-P-L-E. State and explain the principle of moment, and then define the center of gravity of a body, explain its effect on the stability of an object, and then give examples. So just as I told you, we did equilibrium of forces. The first part is a prerequisite. That is what you need to know for you to have this lesson. So let's them. What is moment of a force? So let me write. We are still on equilibrium of forces. Equilibrium of forces. And but now, as I told you, we talk about moment of a force. What is moment of a force? The moment of a force about a point is defined as the product of the force and the perpendicular distance from the point to the line of action of the force. Take note of the word perpendicular distance. That distance must be perpendicular to the force. That is, it must be at right angle to the force. So mathematically, we can say moment mathematically is represented by capital M with a line, a short line underneath it, and it's defined as a force times perpendicular distance. Look at the way perpendicular distance is written in physics. You don't have to write it in words as if it is an English class. No, perpendicular. This is perpendicular. So, and then force, as we know, is measured in Newton. And the distance is measured in meter. That is SI unit. So when you take the product of the two, it becomes Newton meter. That is Newton times meter. So the SI unit of moment of a force about a point is Newton meter. Note that the moment of a force about a point is a vector quantity. And a vector quantity, what does it mean? It has both magnitude and direction. So take note of that. So, and we have said the SI unit is Newton meter. So let me give an illustration of that. Look at this diagram. This is a force F that is acting downward. It's being supported at this point. This is a pivot or a fulcrum. So you can see from where it is supported to where the force is hung. That is the distance. This distance is a perpendicular distance. It's not ordinary distance. What do this distance? Look at the perpendicular. It is at a right angle here to this force. So if we want to calculate the moment of this force, now we now say moment M, the dash underneath it, that is force F multiplied by perpendicular distance. So please take note of that. That is how it is calculated. Now let's go to couple. Couple. C-O-U-P-L-E. Couple. What is a couple? What do we mean by a couple? Very, very important for you to know, because it's in the scheme of work. It's in our syllabus. What is couple? Couple. C-O-U-P-L-E. Couple. Couple can be defined as a system of two parallel, equal but opposite forces acting along, not acting along the same line of action. Two parallel, equal but opposite forces that do not have the same line of action. The resultant force is zero, but the resultant moment, you know, we talked about the moment the other time, is not zero. That is why couple can produce turning effect. Because the resultant moment is not zero, couple can produce turning effects. So the moment of a couple is one force multiplied by the perpendicular distance between the two forces. Let me give you an illustration of that. This is a force F1. This is another force F2. Look at it very well, F2. This is the where it is pivoted. This is a fulcrum. So this is the perpendicular distance between the two forces. This is D. So when we are to calculate the couple here, let's say this is F1, this is F2. So couple is F1 force times perpendicular distance between the two forces. Or it can also be F2 multiplied by the perpendicular distance between the two forces. What are the examples of a couple? We have turning a tap. Turning a tap. When opening or closing a tap is an example of a couple. The steering wheel of a car also produces what we call a couple. So take note of that. So this is it. Then let's go to the principle of moment. Principle of moment. What does it say? It says that if a body is in equilibrium, the sum of the clockwise moment is at about any point is equal to the sum of the anti-clockwise moment about the same point. Clockwise moment is equal to the anti-clockwise moment about the same point. What do we mean by clockwise moment? When the moment goes in the same direction as the hand of a clock, that is clockwise moment. But when it is opposite, it is anti-clockwise. So this one now, look at it. This is like this. This is a clockwise moment. When it is like this is anti-clockwise moment. So take note of that. Very, very important. Let me give you just an example. An example, just a numerical problem that make you to understand it better. It is this. This is a body in equilibrium. It's pivoted here. There is a force of 20 Newton that is hung here. There is another force of 10 Newton here. Then another force of 5 Newton is hung here. Look at it. So the distance between the 10 Newton force and the pivot is 2 meters. So while the distance between the 5 Newton force and the pivot is 3 meters. 3 meters. So we are to determine the distance between the 20 Newton force and the pivot. This is what we are to. Let's say it is X. For this body to be in equilibrium, so since it is balanced there, let's calculate the clockwise moment. I told you the clockwise moment is the one that goes in the hand of a clock. This is the force, 20 Newton. This is the distance X. So the clockwise moment in the hand of a clock. So clockwise moment will be the force is 20 multiplied by the distance X measured in Newton meter. The anti-clockwise moment, there are two forces there. We have a force of 10 Newton anti-clockwise moment. So we have 10, look at the distance. The distance here is 2 times 2. So we have 20 Newton meter. For the 5 Newton force, the distance is 3 meters. So we have the second one, that is 5 multiplied by 3. That is 15 Newton meter. So you have to take the total of the first anti-clockwise with the second one. That is 20 plus 15, because they are in the same direction, Newton meter force. Then that is the total is now 35 Newton meter. So the clockwise force is 20x, while the anti-clockwise is 35 Newton. Because the rule is balanced, then you now equate the two. So you now say 20x equals, that's clockwise moment, 35. Then find x, divide both sides by 20. That's this one cancels out. Then we have about 20. Then that we have 3.5 divided by 2 and becomes 1.75 Newton. This meter, because it's a distance. So for this rule to balance, the 20 Newton force must be at a distance of 1.75 meter. So take note of that. Now let's go to center of gravity of a body. The center of gravity of a body is defined as the point through which its resultant weight acts. Through which its resultant weight acts. That is the center of gravity of a body. For a uniform body, the center of gravity is always at the center of that body. But if the body is not uniform, it cannot be. So it has to let's just talk about, we have to talk about uniform body, not the ones that are not uniform. Let's just give an example. Like the center of gravity of a meter rule. A meter rule is 100 centimeter. So the center of gravity is at the 50 centimeter mark because it is uniform. The center of gravity of a uniform circular object is at the center of that object. And center of gravity is represented by CG. So just take this. The center of gravity of a sphere is at the center of that sphere. While the center of gravity of a rectangle or square or a parallelogram is at the intersection of the diagonals. You know, those lines that are drawn across the angles, the edges of those objects, they are called diagonals. So those where the center of gravity is the intersection. And when you do that, so go and draw the diagonals of those, and then you let me see where the center of gravity is. So in summary, we have talked about the moment of a force. I solve a numerical problem for you for a better understanding. Then we talk about a couple, the center of gravity of a regular object. So let me just ask you a few questions so that I will test your understanding. What is the moment of a force about a point? Yes? Okay, thank you. What is the SI unit of moment? Yes, correct. For a uniform body, especially, let me give you a meter rule. Where will the center of gravity be? Okay, you? Okay, 50 centimeter mark. I'm now satisfied that you have gotten the understanding. Please, keep on reading. Reading is continuous. Look at me now, I'm your teacher. I keep on reading. So, take note. Everybody must be reading. Thank you. Have a nice day.